For a simplicity purpose, I just pasted some snippet of the code at the right side such that we will be diving into the algorithm at the parallelly we will be constructing the code in a pretty understanding manner. So as we know, we have been given the input array and followed by a target. So that's what we will be mentioning. We'll be getting the input array followed by the target. Since we know here the major portion of that array was been lying by looping the array itself. So it will be always beneficial if you can write the length of the array if you can find and store it in some part of the variable. So here the array length is 4 based upon the index we can find, and I'm just making the variable name as if n such that here in the code part I just wanted to show you like this is the value of the numbers, the same integer n for which all these array length is been calculated. And now I just wanted to take I pointer, it lies here. So here the value of I is equals to 0 for me. And I just wanted to take one more pointer which is j. As I know, like initially j value should be starting from the 0, but however j value should not cross or should not touch the I. So I'm just initializing the j value as 0 itself, and my intention was my j value should not touch I value. So that's my intention. And as I know, like my j value should always moves forward direction. So I just wanted to make these three conditions in a for loop. So that would be more useful. Okay. Now, since at I equals to 0, there is no point of occurring this portion of the for loop. So I just wanted to increment the I into the other direction. Like, let me just increment the I. So now my pointer has been moved forward. At this point, it will be like now my j will be at the index 2. So eventually, as to find the value of the both, which is nothing but 2 plus 7. If my summation has been reaching the target, I just wanted to return that particular solution. So here my summation itself, even the first condition, it just reached the target. So I wanted to make the values and I wanted to return my solution. So that's how I will be using here. And what if I was unable to find the target? Let's say my target is some 10. So it's like I was unable to find my target. So literally I was not able to execute this code. Then eventually what I has to do, if my j has been reached at the end, I has to end this inner for loop without any kind of progressing. So this inner for loop has been ended because here I didn't find any kind of solution when I is been at one position. So I just wanted to make the I to move forward. So up to what position the I will be moving? It will be moving when it will be reaching less than n. So that is the value I just wanted to show you. So you wanted to make I that should move up to n position. So for the timing, I has been standing here, and these conditions are being fitted in a for loop. Now, this part of the construction of the code helps you in exploring the J value here, and it won't be going here. As I move forward, you'll be exploring this value, which is nothing but this summation. This summation is not equals to target. So you'll be moving forward, not equals to target, moving forward, not equals to target. Then eventually our loop has been ended up. So it's like your eye has been reached to the end. When your eye has been reached to the end, even this topmost for loop has been ended. So when you don't find any kind of solution, you'll be simply returning a no solution. Before diving into the optimal solution, I just wanted to show you one thing. Like one small observation is like, let's take when you are at the indices 2, that is, you are standing at the 11th element. You literally wanted to find an element J, which is been from the backwards, that should give you the target 10, which is nothing but the only element that satisfies is nothing but -1. That can be found like target minus the element in which you are been standing, that is nums of I. So here it is 10 minus 11, which is of -1. So this is the only element that can able to satisfy our given target. For finding that element, you are literally traversing linearly. Or when you are in the 15th position, let's take one more example for the better purpose. When you are standing in the 15th position, to reach the target 10, you literally expecting -5 element in your linear traversal. So this comes a small observation like, for finding an element, you are linearly iterating. So can we optimize this? Here comes the optimal solution.